Yeah, staat die aan? Okay. Welcome, everybody. I heard at least one spectator wanted to be in English, so I'll try to do it in English. Welcome to my talk about Docker. I'll have no PowerPoint prepared. I'll just be using Visual Studio and the Azure Portal to show my stuff. First about me, I'm Bart Kooijmans. I'm a developer of .NET with last 10-11 years for now. And the last 4 years I've been working with Azure. And since this year I'll work at Team Rockstars IT as a consultant. And in the last years I have been working with Azure and I've grown very fond of it. So I'd like to share my Azure with you. The thing that I would like to show is Azure containers. This is a sneak peek of the Azure Portal. Is anyone familiar with Azure yet? Anyone, anything with Azure? Oh, well, a little bit. Okay. Anyone familiar with Docker already or anything? Okay, same amount. Okay. Well, my assumption is that the use case for my example is that there's some VM somewhere. It could be on-premise, it could be on your local machine. It could also be in Azure already, or Amazon, or what VM provider that you choose. But maintaining it can be hard. Also, you need to maintain it yourself, which could be hard in itself as well. Therefore, I have provided a little example, which does nothing else but check a queue for a message, an Azure storage queue, and then in an infinite loop keep checking that queue for messages, and if there's a message, go work it, and if that's finished, go check again. So among the Azure people, does anyone know storage queues? It's been there a while. Storage queues is you can have a storage in Azure. You can have a storage account in Azure and you can use it to store blobs, files, tables or queues. Basically the three things are blobs, tables, queues, and which I use is queues. Anyone using service bus or message queue or any queuing mechanism? Yeah, it's related to that. You can make your own queue. It's a very simple, basic queue. It's a service bus lite, if you'd like to say. You have limited functionality, but the functionality that you have is very powerful. So I'll have a queue and I can put messages on it and the messages can get pulled off. That's basically the functionality you can have in a queue, and I'll use that because I'll check that queue, and if there is a message on it, I'll work it, and the work is simple, delay the amount of the integer that you passed. But a scenario is that how do you deploy this software? A very common thing that if you attend lots of conferences and talks, everybody talks .NET Core or DevOps or automated deployment, but in my experience, 90% of all stuff just gets deployed manually by a so-called Xcopy deployment. So what you then do is you build it on your machine, or if you're lucky on a build server, and then you'll just copy it to the machine where it's running, and then you have the local virtual machine somewhere via an RDP session or SSH or something. And then you get the question, can we scale up? Okay, well, I can add another VM. It's a cloud. I can easily click another one. So I'll click 2. Well, can you make 5? Well, okay, it takes me half an hour, but I can do that. But then it gets painful to do that. Then you'll need to check for other things because you need to maintain it as well. If you need to maintain 5 VMs, then you need to go 5 times with an RDP session to it, copy it 5 times if you do it manually. Or if you're lucky, you'll have a pipeline in place, but still, you have 5 VMs to manage, and that's where my eye was catched by. No, that's not right. That's why I looked into Azure, and I saw the Azure Container Instances. It's like a a VM as a service, as I'd like to call it. You can have an Azure Container Instance and you'll run a Docker image in it. So first you need to make your VM setup as a Docker image, and then you can deploy it easily to the cloud. So has anyone heard of Kubernetes? Yeah, everyone has heard of it, and does anyone do it actually? 2 people? Yeah. Well, container instances are very suitable if you in a strict pass solution. If you have one, or you can count them on your fingers, VMs, then container instances can be useful because you can only have one container instance at a time. If you have multiple, you need to have multiple machines. You cannot have one Docker image and spread it across. You cannot have one container and have 5 instances of it. You need to make 5 containers of it. It's like a one-on-one solution with VMs. But the one thing that it's easy is you have a deployment out of one Docker image. So let me show me my example. I have my program. I'll build it. It's already built. I'll go to my release. I make a PowerShell window and I'll run the software. And it checks for a message. And if I go to my storage account, go to the queues and add a message to it. So 5 means work for 5 seconds. Then you'll see it come by here. It says found new message, working for 5 seconds, and then it starts pulling it again. Yeah. So now how can I make an easy Docker switch of this? Well, Visual Studio has made it very easy. The basic thing about Docker is that everything is running in the command line. Docker has a very powerful shell software, and you can see the -- help. It offers you about anything commands you can do. Interesting things are things like run or build or pull and push, which if you use a version control system like Git or TFS, then you'll be familiar with it. But I'll come to that later. Visual Studio has an out-of-the-box option to make it Dockerized, which is right-click, add container orchestrator support. And then you can choose for Service Fabric or Docker Compose. Well, and in my case, I'd choose Docker Compose. And what it does in the background, it adds a Docker Compose YAML file and a Docker file. It does that for you. And if I check them, the YAML is just a file of, well, build this Docker file. It's an orchestrator for that. And the Docker file is what does the actual magic. And that says, take this runtime, this base Docker image, put your app on it, and when you start it, automatically start that exe. So Docker works with it's very declarative. It works by inheritance. So you say, this is the declarative way of defining a Docker image. You say, given this base image that someone has provided, you can take a very lean image, but this is already one that's prepared with about 4.5 gigs of something that's needed, like Windows and the .NET Framework 4.7.2 in this case. But you could also use a Linux image if you're using that. Docker is originating, I guess, from Linux world where they're very small images. And if you come to Docker with Windows .NET Framework, for example, you get used to very big examples, big container images. And that's another good way of, well, switching to .NET Core or a Linux or something if you redesign it, because those images are significantly smaller. If I take about, let's talk about a Docker image for Ubuntu. It could be 50 megabytes or 100 megabytes, but a Docker image of .NET Framework could be 5 to 10 gigabytes. So that's a lot. And if you take .NET Core into account, then it takes it goes back to the megabytes. So it's interesting to talk about .NET Core later. Well, I have a release build. That's important. In debug mode, it does nothing with it. In release build, if you build it now, I'll build it. And what you see is that it starts building the Docker file step by step. It takes that image, but I already prepared that, so I'll not let you wait for downloading 13 gigabytes. It's caching it using cache. It sets my work there to app, copies my software to it. It's done everything, and then it gives it a number and a tag. Yeah, and what Visual Studio does for you is in the object folder, it adds a bin and release folder over here, but it also adds a object Docker publish folder with a copy of it. So it's always there if you build it, and this is the one that gets copied over here. If you say copy, it's object Docker publish. And now I can view my Docker images. And you'll see that about a minute ago, it made a new one of 4.5 gig. It's called this with the tag latest. So now I could run this already. You saw that I run it over here with the local version of bin release. But I could also run Docker run. If I do, well, let's see the -- help first. Docker run has some sub parameters as well. Run is the command and then the parameters in it. -- rm means remove it when it exits, so you don't have much clutter on your system. Docker run --rm, and I want to go inside it, so I'll provide the IT for interactive terminal, and I'll need to provide the Docker image I want to run, which is this image ID or the repository latest, but the easiest way is just provide this ID. You don't have to type in all of this, just as long as it's unique. So mostly the first 3 letters are enough. 9C5. So now it starts my Docker image. And it's waiting for some message to arrive. Docker is explicitly very simple if you compare it to normal Windows environment. In Windows you'll get used to a C drive, a D drive, an E drive. For example, you have software on C but you log it on D, the logs, or you log it, or you have a temp drive on D. Docker is not. You cannot use Docker easily with that. The assumption with Docker is that it's very lean, it's temporary, so just put everything on the C drive. It's a sandbox, so it's not your actual C drive. Some assumption, well, everybody uses /app. You can use everything, but everything what you want, but app is sort of a standard nowadays. And we can also go into that machine. So you notice that I have a standard entry point, but I could override it. I don't want to go into the worker.exe, but I want to actually go into the machine myself. So I'll say start command.exe. Then it spins up the VM. And I can do my own stuff. You'll see it's like an SSH or RDP session in the console. It's like you have your own Windows system here. There's a /app there. You'll notice it talks about a C drive. But when you actually configure something on it, you can let the C drive, you can remove it, it's not important. /app is working as well. So this is inside. You'll see my DLLs and exe in here, and I could also start it, of course. That's what it does automatically, but now I've done it manually. Well, now we have a Docker image. We'll run it locally. That's very easy for testers. So they have the exact image that is running elsewhere, and not only the exe and DLLs and the config. But now I'll push it to the registry. For public repos, you have Docker Hub. It's like a GitHub, but for Docker. And Azure has its own private repository. You have a container registry. You can create it. And it's basically your own versioning system for your Docker images. You see, I have a basic plan which provides you for 10 gigabytes. You could also pay more and you get 100 gigabytes or even more. But for now, I'll have enough with this. You see, I have two repositories. I prepared this with a worker and a sample app. In this, the worker is what you saw before, and the latest is the Docker image that's over there. Now let's push it over there. I'll need to exit my Docker image. So I'm back in my own world. And let's inspect the Docker images that I had. So it made me a new one. The previous one was 38 hours ago and was tagged latest. But now I want this to be the latest. You could also use semantic versioning, but for my example that is not necessary. So I could tag this, and I'll say Docker. Well, it's already tagged with this one, but I want to tag it so I can use it in Azure Registry. So I need to prefix it with the registry, or else it will end up on Docker Hub or something. So I can tag my 9C5, and I'll call it, well, let's call it latest again, or call it V2 for that matter. And you'll see I'll have a new image. I need Docker images. I'll see I have a V2 over here, and now I need to push it. Push. And now it asks for my credentials, because I haven't provided it. I need to log in. It's a very simple process. You say you install the Azure CLI. That's a tool that's you can use it for anything that's working in the portal, but on your own CLI in PowerShell, for example. When I log in, it says it provides me with a message that says we've launched a browser. So go to that browser. I want my other. You have your login scheme, and then it returns, says okay, you're logged in. Very easy. And then you also need to log in onto your registry, so such that it's known on your command line. Login succeeded, and now I can do a Docker push. Now it is pushing all the gigabytes up to the cloud, but it's very very clever in caching. A layer already exists, skipped foreign layer, already cached, and it pushed my new things. And you'll see in my repository that a v2 should be here now. Where did it go? Oh, it's still busy. Yeah, now it's finished. Now the v2 is here. Now I can deploy it anywhere from this hub. The easiest thing to do by hand for manual purposes is right click here or click the dashes, the dots, and use run instance. Then instance means container instance. It ends up in a container instance. You provide a name, amount of memory, and location, West Europe for example. And you press OK and it gets deployed. That takes 10 to 15 minutes to do that. You could also, if you know the entire container image that you've pushed, you can go directly to container instances, do add, and fill the form over here. You have very much more config work, like environment variables you can use, which in the classic VMs there are no environment variables that you can provide from outside, and in container instance you can. So you have one Docker image and you can use it for a dev, QA or prod environment. You'll select a private image because it's Azure Registry and not Docker Hub. You can provide your image name, registry, username, password. And well, again, if you click create, it gets created. Well, I've done that already. And okay, yeah. It ends up as a registry. It can see it takes a while to do that. An hour ago, when I prepared this, I already say create or started. It was created already, and it took well almost 20 minutes to just pull in the 4.5 gigabytes. So that's another reason to get that to very small amounts. But what I was growing very fond of the Azure Container Instance is that you can use the portal to manage your machine. You don't have to go to the machine itself. You don't have the machine. It's just running somewhere serverless. And your endpoint is just this. You can see the properties of it, which showed the environment variables. And you can show, scroll up. You can show the events, which I did before, logs, and I can connect in the browser directly to that machine. So I don't need any RDP program to do that. Well, in events it showed what it was doing. It's pulling the image, then it's done pulling and it gets started. And you'll see that when it doesn't work, for example in this one, or this one, you see that it has its own fault mechanism. So it was pulling images, but it couldn't pull images because it had no internet connection. So it failed, and after 4 times it said, well, let's back off a little, let's wait until it gets better, and if that doesn't happen, then it eventually gets terminated, so you have to investigate it yourself. So it is very sophisticated in error handling. You'll need to have an infinite loop in your program because otherwise it already closes. That's what is my sample app. It's just a .NET Core app that does some ASCII art in the command line. And when it's running, it's very easily pulled because it's a very small image, but it exits when it's done. So it showed hello from .NET Framework, and that was what the image did. That's all it did, and then the Docker image was disposed. So now I have my long-term running process. I can see in the logs what this is actually doing. I could also see error logs if it had You see here when it gets wrong, you see a stack trace, and maybe you could investigate something on it. And if it works, you'll see that it's just working on it. Well, let's have a storage. Go to the storage account. The queue. Put a message on it. Oh, that's a 4. I don't know if it's auto refreshing, but eventually it will end up found new message 4, working for 4 seconds, and when it's done, it goes back to business as usual. So this is a very real life scenario in which I did a lot before. You have a software somewhere that's pulling a queue, and it doesn't matter where it's running. It's sort of a black box both ways, because it doesn't know where it's running. It just pulls a queue from somewhere. The queue is always could be also always the same, and the other way around, the one that's triggering the queue, it doesn't know which is consuming it. So you fire a message somewhere from go work for 5 seconds, and I don't know who. It doesn't matter who gonna act on it, because if you have 5 machines running, well, then you can have 5 times the power, and scaling in Azure is very more easily than on-premise, because you have it's difficult to have more disk power or server power, because you need to actually buy it and have provided for years after that. In a container instance, you can say I run it for 5 minutes, and then you actually pay it for 5 minutes, and when you stop it, you stop paying for it. So it's a very, for short-term scenarios, I need to have another burst of, well, this day I'll have a deadline, I need to work some harder, let's have 5 more machines. Well, you pay for the time the machines are running, and if they're done, it's only cents for the disk storage that it takes on Docker. Okay, did I? Yeah, and the last thing then. Yeah. You could also go into this machine with Connect. It provides very Linux-based bin bash, but you could also provide your own, like I did before. I'll say command.exe. Notice that it's all in the browser, and it's like I'm into this again. It's a very small window now, but you can see that's all here, and I could even start anything on it, or I could inspect the machine for what it's worth. Yeah, are there any questions so far? Okay. Let's see what I forgot. Events. Yeah. Docker has a very powerful command line. You see that we had used the run locally, the pull and pull we didn't use, we used the push, and you could also inspect your images if it's locally running. Docker, where's my run? If I remove the -it and I say do it in a daemon or detached, then it gives me a hash of, okay, it's running, this is my identifier. And you can look into a process and see it's running, and you could also attach a log to it, which is what Azure Container Instances will do for you. Docker logs. Oh well, I need to provide this one. Docker logs. So notice that I have an image ID, but if you spin it up, it has a container ID. So if I want to connect to the specific container that's used on this image, you can have 5 containers of an image, then I can see the log of that image. You can also, when you have docker ps, you could also kill that image. It's like your own process explorer. Docker images, well, if you end up in the registry, you could also easily attach it to an Azure DevOps solution. Anyone using Azure DevOps already? You'll have a pipeline you can configure a pipeline in it that says, well, connect to this registry, pull the image, or, well, let's start somewhere before. You attach your repo on it, your software. I did now a build and push on my own machine, but you could also do it in Azure DevOps. You'll say, this is the Docker file, that's the same stuff, but when you do a build on your build server, it does this stuff on the build server, and then you can configure what I did manually, like the Docker. No. Docker. Well, it basically is a Docker build that you did, but I could also do the, when it's built, I could a Docker tag and a Docker push. I could do that myself, but you could also configure it in the Azure DevOps. And then the deployment gets even more easily, because you can use everything that I do in the portal. You can do it. You can do it by the Azure CLI. Let's have some Azure CLI. Well, this is what I would like to show. I'm not gonna execute it, but you notice that I had Azure AZ login and AZ ACR for Azure Container Registry. There's also an AZ container. You can create with all the stuff that I did in the portal. You can automate it. You could set this in Azure DevOps, and then you'll say, this is my image, this is my credentials for the server, username, password, and, well, create it. Create 1, 2, 3, 5. You could create as many as you want. And the real scenario is that if you want a more sophisticated infrastructure or orchestrator, then you'll use Kubernetes, but I'm not gonna touch on that. Azure Container Instances is it's designed for using one container image at a time, or one Docker image. If you want to scale them all to 50 images, you'll look into a more Docker Swarm or Kubernetes solution. Well, that was what I was planned to say on this presentation. Anyone got a specific question to elaborate on? No. Well, then I guess my session is over. Thank you very much for attending.